Okay, this is the latest state of the pendulum system, and it appears to work, albeit with just over half-metre pendulum. And you probably noticed there's no sensor here for the driver. I decided that having a home position for this driver mechanism was unnecessary, so that was a bit of a saving. So all we've got is the centre position sensor and the maximum swing sensor. Right, let's start it up. So this is effectively power on with the pendulum stationary. And that first push is just sufficient to make the middle sensor trigger. And I don't know if you can see the display here. I've got the first 4 digits is milliseconds for the swing period. And it says 1.642, 1.6 seconds. I've not done the sums actually to make sure that agrees with it's a 68 centimetre pendulum, so maybe you can do the maths. And then this second 4 digits, this currently says 552, is the number of milliseconds that the controller delays for before doing the actual push. The controller works out when the top dead centre is, I suppose if you want to call it that, the furthest left hand position of this conrod, and then tells the driver to wait this number of milliseconds before initiating a push sequence. So you can see the swing's gradually building up. The driver only moves a small number of steps for any particular push because there's still an issue with the driver motor stalling. If it tries to push too much, it will get out of sync with its step position, and the pulses that the controller sends to it will make it go in the reverse direction. So the way to prevent stalling is it does just a few steps at any one time. So even if it does stall and go backwards, it doesn't matter. And then it also disables the motor as soon as the push is finished. So the motor is freewheeling effectively, and the pendulum can then push the driver out of the way, but because it's not tightly coupled, the driver motor will adopt its own natural step position and be ready for the next push. Right, you can now see the maximum sensor triggered there. As soon as it triggers, it disables the drive mechanism. And as soon as it stops triggering, the driver switches back on again. So the thing should give a kick every now and again. This is its normal running state now. I was continually monitoring this mid-sensor, so it's adjusting itself for any variation in the pendulum length. I don't think it would be much, it would just be due to temperature, but it adjusts its figures every time. And if the pendulum gets compromised, like somebody knocks it, it will sort itself out. I can simulate if we had a power cut for a few minutes and it comes back up with the pendulum still running. That was another consideration. Where's my reset stick? I'll reset the controller. There's a little button on it to reset it. At the moment it goes through a little menu system, so I can tweak some settings. So I've got to press a button to make it start, but in the target it will just automatically go into this routine. So you can see the driver has remained in sync, or it's re-established synchronization with the pendulum. One problem I had to start with was that if you have a symmetrical swing, you can't tell whether the pendulum is to the left or to the right, and you don't know whether this drive is going to be in the right position, and you'll be fighting the pendulum instead of enabling it. So by offsetting the middle sensor, you get a lopsided swing from the sensor's view, and the controller can measure the times when the sensor is off on one side and on the other side, compare the two, and deduce which side the con rod really is. And interestingly, that solution also solved another problem, which was that due to the limited power of the driver motor, it was quite hard to push the pendulum from rest sufficiently for the sensor light to go out. And by offsetting the sensor, that made it a lot easier. So if there's a phrase for the opposite of Murphy's Law, then this was one of those cases. So I'll just stop it manually. So the design requirement was that this was going to be completely self-starting and self-regulating no matter what. But time will tell. I'll just move the camera to get a better shot of that display. I don't know if it's coming out or not, but there we go. The left-hand number is the swing period in milliseconds, 1638, and the right one is the time to give the kick. Well, there is a bit of fluctuation, but I don't know whether that's just the mechanics of the thing or what, but the timer is running on a 1 millisecond resolution. And that's the pendulum there. I've got a ½ a kilogram weight at the bottom to simulate what I think, well, I guess, would be the weight of the target pendulum, which is going to be 2.5 meters. I found a shelf that I can put this clock on that will accommodate a 2.5 meter pendulum, so we'll try that next. And it's tricky to put the clock in its target position because that means getting some scaffolding out to put it on the ceiling, but this shelf would do for now. So fingers crossed for next time. Thanks for watching.